Good morning. Welcome to AP Computer Science A. Today we are going to go over section 7.5, selection sort. We're going to go over three types of sortings in this class. We're going to go over selection sort, insertion sorting, and binary sorting. Now, insertion and selection are much easier to code, but they're not as fast and efficient. Once we get to Unit 9, we're going to cover recursion, which is implemented in your binary sorting method and algorithm. And that one can be a lot more challenging to code. But the good news is that you actually don't have to code either one on your AP exam. They won't be a part of your FRQs. They'll be part of your multiple choice. You need to be able to either know which is the next order on the next step of a sorting, either insertion, selection, or binary. Or you need to be able to recognize the code. And if you have your notes, the code is given to you in this section that you have to code in your algorithms tomorrow. Today, what we want to do, we want to be able to go over the logic and the process. So I'm going to be using this animal sorting that I created. And so you should have it with you. The way the selection sort works is that you're going to have a for loop inside a for loop. So you're going to have a nested for loops. And we are going to go through the process and we are going to find first, we're going to select the smallest element in your array. Now we only have integers in here, so we're going to select the smallest number, the smallest integer. And your outside loop is going to start with I equal to 0. And what we need to select, we want to be able to select the minimum value. And we're not going to keep track of the minimum value. We're actually going to keep track of the minimum index, the index of the minimum value. So therefore, we start. And we remember that whenever we're looking for the minimum value, we always assume that the first one on index 0 is the smallest value in your array or array list. And for your visual representation, I'm just going to keep a copy of it right next to it. So our minimum value, we're going to assume that it's in index 0, which is 57. And now your inside loop is going to go through and say, is 19 smaller than 57? Yes. If it's smaller, we are going to replace that index. And for visual representation, I'm going to make a copy of it here. Your inside loop continues and says, the next one is 80 smaller than 19? No. 26 smaller than? No. 95 smaller than 19? No. 38 smaller than 19? No. 4 smaller than 19? Yes. So therefore, our smaller element is on index 5 now, or index 6. And I'm going to keep a copy just for visual representation. But we are only keeping track of the location of the index of the smallest element. Our inside loop continues. Is 45 smaller? No. Is 14 smaller? No. Is 73 smaller? No. So therefore, our smallest element is on index 6. And now we end our inside loop. And we are going to swap those two elements. We're going to swap the smallest element with the first element, which is at index 0. So we're going to keep a copy on our temp. We're going to take what's on element on index 0. We're going to switch it. And now we swap them. So therefore, our first element is sorted. Our outside loop, I is going to be now from 1. And we are going to find the smallest element from 1 to the rest. So I equal to 1, or outside loop. Then our inside loop starts. But before it starts, we're going to assume that the first element, which is on index 1, is the smallest element. We're going to keep a copy over here just for visual representation. And now our inside loop starts. It's 80 smaller than 19, no. 26 smaller than 19, no. 95 smaller than 19, no. 38, no. 57, no. 45, no. 14, yes. And we're going to keep track of the index. So therefore, our smallest element is on index 8, and I'm just going to keep a copy of it for visual representation. But we are only keeping track of the index. And now we continue our inside loop. 73, no. Our inside loop ends, so therefore we know that our smallest element is on index 8, and now we're going to swap them. I'm going to keep a copy, 14. Now I'm going to copy it here, and now we swap them. So now our first two elements are sorted. Our outside loop continues to index 2, and we're going to assume that the smallest index, and we're going to find the smallest one out of the rest. We're going to assume that our first index is the smallest one. In this case, is on index 2. And then we start. Is 26 smaller? Yes. We're going to keep track of the index and for visual representation. 95 smaller? No. 38 smaller? No. 57 smaller? No. 45 smaller? No. 19 smaller? Yes. So therefore, we are going to keep track of the index of the smallest one. And for visual representation, I'm going to keep a copy here. Or inside loop continues, 73 smaller? No. Or inside loop ends. We know that the smallest element is on index number 8. And now we are going to swap what's on index number 8 with the first one. So therefore, we're going to keep a copy on the temp. What's on index I, which is 2, gets copy on the smallest minimum index. And now what's on temp gets copied to the location I. Or outside loop continues, so therefore I equal to 3. And now we're going to find the smallest element. We're going to assume that the first element, which is element 3, is the smallest element. And now our inside loop continues to the next one. Is 95 smaller? No. 38 smaller? No. 57 no. 45 no. 80 no. 73 no. So therefore, we know that our smallest element is on index number 3. Now we can have an if statement saying if the smallest index is the same as the I, don't do anything, but we can just do a swap. So we don't have to do additional coding. We can say, okay, we're going to swap it with itself. So we're going to keep a copy of it here, copy it there, and now we can copy it back. So the algorithm will work the same. Our outside loop continues. So now I equal to 4. And we're going to assume that the first element is the smallest one. Or inside loop ends. So now we are dealing with the last two. We are going to assume that the first one is our smallest. And now is 95 smaller? No. So he ends. So therefore, the smallest one is on index 8, and we're going to swap it with itself. And now, once we get to the last one, we don't need to do the last one because we know that there's only one element. That one's automatically sorted, and we are done. And therefore, our array or array list is fully sorted. So that is the algorithm for a selection sort. You'll do this in you'll code it in your class tomorrow. And remember to go over your notes, and the algorithm is here. Have a great day, and I'll see you tomorrow.